today we're going to look at sum and products of roots. So we're going to be looking at the roots of quadratics or cubics or higher polynomials, and we're going to find out what the roots add to or multiply to. So our first rule for a quadratic, if the roots are alpha and beta of the quadratic ax squared plus bx plus c equals naught, the sum of the roots will always be negative b, so negative this guy, on a. And the product of the roots will always be c on a. So let's have a look at that. So if the roots are alpha and beta, we can say that x minus alpha must be one bracket and x minus beta must be in another bracket, and I've got to put an a out the front because it's got to make ax squared when I expand. And so that should equal 0. Okay, so I've just rewritten this in terms of its roots. Okay, so let's expand that bracket. So we've got x squared minus alpha x, I'll do it the long way, minus beta x plus alpha beta. And so I have a x squared minus alpha plus beta x plus alpha beta equals naught. And so then when we expand that, we can see, that we have a x squared minus a alpha plus beta x plus a lots of alpha beta. And this should be the same, it's equivalent to ax squared, that's fine, plus bx plus c. So now we can say that b is the same as negative a alpha plus beta, or in other words, alpha plus beta is negative of b on a. Also, c is the same as a alpha beta, so alpha beta is c on a. Now that we've proved it, we can just use it, and that's probably much easier. So here we're told that alpha and beta are the roots of this quadratic. So the first thing I'm going to do is I'm going to write a, b, c. And I'm asked to find alpha plus beta, or the sum of the roots. And we know the sum of the roots is given by negative b on a. So in this case, negative 6 on 2a, so that's 3. So without factorising it, finding the roots and adding them up, I can get the sum of the roots just by using the negative b on a. I can get the product of the roots by using c on a, which in this case will be 1 on 2. And they're your standard types. Okay, a couple of harder ones now. How do I find alpha squared plus beta squared? Well, I'm going to have to use a little trick. I know that alpha plus beta all squared is alpha squared plus 2 alpha beta plus beta squared. I've just expanded that perfect square. So this would mean that alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta. And in the previous question, part A, I worked out alpha plus beta was 3 squared minus 2. Alpha times beta was a half. So I'm just subbing them in. So that's 9 minus 1, 8. So this is a very handy trick. Some people will just remember this, or you can just derive it quickly. D, whenever we have fractions, our first step is we'll express them as one fractions. So we'll go alpha plus beta all over alpha beta. All right, I know alpha plus beta, what was that? 3. I know alpha beta was a half. 3 divided by a half is 6. Okay, example 2, slightly harder. We're given one root, it's negative 4, and we're asked to find the value of k. So first of all, this will be my C. So I've got A, B, C. All right, we don't really know what's going on. So we're going to let the roots be alpha, and obviously -4 is the other one. Rather than alpha and beta, we're going to go alpha and -4 because we do know something. Okay, we also say, all right, don't know what to do, so I'm going to say the sum of the roots first is -b. So -3 on A. A is 1. Alpha minus 4 is 3. So I can see that alpha is 7. All right, but it didn't ask me to find the other root. It asked me to find k. What else do I know? I know the product of the roots, alpha times -4. So -4 alpha is C on A, which is k minus 2. And I just worked out that alpha is 7, so -28 equals k minus 2. So k equals -26. So sometimes before you think too much about the problem, we just do sum of the roots, product of the roots. I'll get a mark, and then hopefully I'll realise how to solve the problem. Okay, final example for quadratics. In this one here, we want to find the values of k if the quadratic equation, a, b, be careful at negative, c, has equal roots. So we could think of a couple of ways to do this. We could use the fact that this would mean the discriminant equals 0 and solve for k. So I do b squared minus 4ac equals 0, solve for k. And I think that will actually be easier in this case. Alternately, I could let the roots be alpha and alpha, and I'll probably go that way because that's sort of the point of this question, but I do think doing this might be easier, and you might have a go at both when I finish the video. So we're going to let the roots be alpha and alpha because they're equal, and so I know the sum of the roots, alpha plus alpha, or 2 alpha, should equal -b, so k plus 2 on A. And the product of roots, alpha squared, equals C on A, k plus 1. And now I need to find, what I'm going to do, find k. So I can find alpha and go back and find k. I think that will be one way to do it. Or I could say, okay, alpha equals 1/2 k plus 2. And I could sub that in here. So I'll go 1/2 squared, 1/4 k plus 2 squared. So I've just subbed this in for alpha squared equals k plus 1. I'll times the 4 over. Expand this bracket. Cancel. Oh, cancel. And I get k equals 0. Interesting. That would make it a perfect square if I look at that, and I would get one equal root. Or, as I said, feel free to pause the video, find the discriminant, set it to 0, and solve for k, which is probably the way I would have went in a test. Okay, consecutive roots. I'm going to let the roots, and you probably should say that, let roots be alpha and alpha plus 1. Okay, so that's 2 consecutive numbers. And again, we don't know what to do, but we start by going, okay, the sum of the roots, 2 alpha plus 1 equals -b on A, and the product of the roots is C on A. And again, we want to work out k, so what I'm going to do is I'm going to rearrange this one. So I'll minus 1 off both sides, I think. Halve it. It's going to get a bit messy. And then I'm going to sub it back in to this second equation here. So alpha, that's 1/2 k plus 1 times a half k plus 1 equals k plus 1. So messy. Alright, so I might just get rid of the half, so I'll times that to the other side. Being very careful there. And so now I've got k plus 1, and in brackets I've got a half k plus a half plus 1, 3 on 2. And again, I'm inclined to double as well, so I'll go k plus 1, only double one of the brackets, double that and that, and now that's 4k plus 4. And of course you can do this however you want. You might do it a little bit differently to me. So that's 4k, and that's 3. It's really nice that the 4k's are cancelling for us. Save us solving any quadratic. So what do I get? K squared equals 4 minus 3 is 1. And yeah, there's no restrictions on k. So therefore we could have k equals plus or minus 1. Yeah, that was sort of fun. Okay, last one. This is actually a really common question. Reciprocal roots. So we're going to let our roots be alpha and 1 on alpha. Okay, so the sum of the roots, alpha plus 1 on alpha, is k plus 2. And the product of the roots, alpha times 1 on alpha, will equal k plus 1. So you notice I've just sort of blindly written both steps, but I can see that this is the only step I need because the alphas will cancel. And I'll get k equals 0 again. That is very interesting. Let me just double check. It is quite interesting. And I think I realise why. I think the roots, when you think of this, when k is 0, this makes sense. Yep, that would become x squared minus 2x plus 1, right, when k is 0. And so we've got a perfect square. And so the roots are 1 and 1, 1 being its own reciprocal. Okay, so that was a little bit odd. They don't usually turn out like that, but it does make sense, okay? So just get rid of that now. I don't need it.